there. Yeah, that's right.
These rocks were collected in South Africa in some of the oldest rocks in the world. It's about 3.5 billion years old. And they were formed in ocean basins. And they were laid down on the ocean floor. What you're seeing there is actually a piece of a rock that he's using the laser on. So imagine what's happening on the ocean floor. There's rocks that are forming at the ocean floor, even as they are today, but 3.5 billion years ago. And they're sitting down on the ocean floor, and they're forming in equilibrium with ocean water. So they're capturing the original signal of that ocean in the rocks, and then when they solidify, they preserve that, hopefully, for 3.5 billion years. So what we found out, once we analyzed these, we had both hydrogen isotopes and oxygen isotopes, and we could calculate a temperature of the oceans. It was a cold ocean, or at least a tepid ocean. That's one thing we found out, which was really fascinating. The second thing is we found out that the isotope composition of the ocean was very different than what we had previously assumed, and it had a lot more hydrogen in it relative to deuterium than modern oceans. The significance of this is it allows us to identify the types of life and where the origin of life stem begins and what kind of environment was that. And so that, to me, is one of the most important aspects of understanding what our temperature oceans were.